Excuse, guys. So we're saying that the graph that is here, guys, I want you to look at it, understand everything, especially the vertical and the x-axis of this graph. Do you see that on this side you are saying expected return, and you are saying low expected return? On top we're saying high expected return. On the other hand, do you see, guys, you are saying risk or volatility or standard deviation? The good part of it, they're just telling you that risk or volatility, guys, is the same as standard deviation. I'll tell you, guys, as we proceed with the module, you're going to realize that the word volatility will come in most cases, but someone will needs to say, what is this volatility? That's the risk, that is standard deviation, right? Volatility is the risk, is the standard deviation. So master that for other modules to come. I'm sure you'll be able to understand that. Then we're saying we're having expected return on the other side. We're having standard deviation on the other side. Let's just say standard deviation for easier sake. And I'm sure you still remember that we explained about this thing. We said the expected return, that's the risk. Then standard deviation is the risk. So this efficient front here is measuring risk and return. Expected return or return on the other side, risk on the other side. And on risk, it's also the same. Lower risk starting from here, higher risk here. Now what we are saying, let's start with this dot. We are saying at this dot, you see that the risk is here. I'm saying the risk is here. If I'm drawing up, then the return is here. Do you see it? Okay, let me come back. Do you see this dot? The risk is here. Do you see that the risk is a little lower for this dot? If I go back this arrow, you see we are coming back. So the risk is less, but the return is higher. Tell me, guys, if it was you, which one would you choose? Let's assume this one is A, this one is B, this one has got a risk that is here, and the return that is here. This one has got a risk that is here, and the return that is here. Which one are you going to choose if it was you for investment?
I can try maybe A.
Maybe A. You are correct, actually, but I don't know if you are willing to explain why.
I'm thinking the return is a bit higher than the risk. I don't know if I'm right.
Yeah, you are right. If you want to even proceed, we explain more, but you are correct. It's correct to say the return for A, do you see that A here? The return is higher compared to B. Do you see that B is down? The return is high, and we really love the return. And again, the risk for B is much, because you see risk, we are coming from here, A has got this risk, and you are proceeding here. You see the risk has increased. So A is better in all areas. It has got a higher expected return and a lower standard deviation compared to B. Is this making sense, guys? Okay, let's choose another one. This one will be a bit tricky, and might need, even sometimes you might need some calculations. If I draw now, let's come to this dot. Let's make it C. Down. So it means this is the risk, right? And let's find the return for C. This is the return. Let's compare it with the D here. The return for D. Sorry guys, today I got some flu. Do you see now we've got C and D? You know, if I tell you to say which one do you choose, what are you going to say, guys? You see, now the situation that we're having is a bit challenging. Why? Because as much as D has got a higher expected return than, because it's higher by this, but it has got also more risk compared to C. Right? So in that circumstance, let me not quickly tell you all the details. I know you will not need it for this module, but also there is a module that we tutor, which is also financial management. It's happened that I was open the slide, if not mistaken, the slide. Let me just see. I just want to show you how you manage such a situation, but we are not going to get into that. It's not, I'm sure it's not part of our module. But you see, that situation is a bit confusing because the return, that one is high, but the risk. You see, this is also a topic that we do. Sometimes you may need the notes, because you can see that the information is pretty the same, risk and return, but it's another module. But the information can be helpful. You see, this is risky, what, but this stuff might not be necessary for you. You might now end up giving yourself unnecessary pressure. But we do all this calculation, measuring risk. Risk is a possibility that the actual earning will differ from the expected. We'll do all this in one of the modules. You see, we do the same calculations. So at the end of the day, it becomes easier for us. Okay, so you see what? The example that we have on that one is like this. Flow is not good. Okay, let me show you the example. Okay, oh, now this is a different slide. This is the slide that we wanted to go. You know, I was asking to say, guys, can we have class on the weekend? Because I also realized that at the end of the day, because I have the assumption that some of the guys that we have the class with do not have a background in finance. I feel like I end up explaining too much that we become a little slow. So I may need an extra time. Because I feel like if I also go a bit fast, people will not understand. So you see a situation that we have there. We've got C and D. As much as D has got a higher return, but it has got more risk. All right? So to say we are going to choose D just because it has got more return, it's not true, because it has got more risk. That situation is the same as here. We've got two stocks. Consider the following stocks, X and Y. You see, X has got an expected return of 10, and Y has got an expected return of 11.5, standard deviation of 12, standard deviation of 12. In this case, guys, which one are you going to pick between stock X and Y? And this one I'm sure I'm going to answer me. Which one are you going to pick?
Maybe stock Y?
Stock Y. Okay, thank you. Why? Okay, why?
Because the returns are higher.
Yes, thank
Even
you.
though the risk is the same.
The risk is the same. The investor will consider both risk and return. They will choose an investment with a higher return at the same level of risk, which is stock Y. Let's go to this one, B and C. Expected return 10, stock C, expected return 10, then standard deviation 9, then standard deviation of stock C 12. Which one are you going to choose?
B.
Yeah,
B. We all agree. Okay, if we all agree, let's proceed and see a different situation. Now we're having this one. Investments with different expected return. Okay, if two stocks or investment have different returns and risk, it is not obvious to conclude which investment is the best. For example, we've got expected return 28 for X 20 for y, standard deviation 14 for x, 8 for y. Even investment X provides a return of 28%, we cannot immediately conclude that it is a better investment than Y. To come up with the conclusion, the coefficient of correlation and Z-score can be used. But I don't want you guys to go much further. You see, it can be used to do those calculations, right? One of the calculations, what we can just do is to say, let's calculate what is called a coefficient of variation. Coefficient of variation is a measure of risk per unit of return. So this, you might not need to have it for risk management, but I just wanted you to understand that efficient frontier. We're going back to it. So we are saying, if you want to see which one to choose, because that graph definitely it will have got values, you divide the standard deviation over the mean to get what we call the coefficient of variation. So we are going to say 14 divided by 28 for x, then 8, the standard deviation divided by 20 for y, then you get 0.5, you get 0.4. Then we say use the coefficient of variation to explain an investment with a better risk-return trade-off. Okay. I'm sure most of you might not be aware of what is coefficient of variation, so you cannot conclude. We're saying coefficient of variation measures the unit of risk per 1 unit of risk per 1 unit of return. The return is the mean and the risk is the standard deviation. CV is a statistical measure of the variability of returns around the mean, or around the expected return. The mean, guys, is the expected return, right? The CV becomes a useful tool in measuring different investments. If the standard mean ratio is smaller, it translates to less risk per unit of return. It incorporates the risk-return trade-off theory. The investment with the lower CV is ideal and vice versa. So in this case, we are going to pick which stock?
Zero four.
Stock what? 04, right? Which is stock Y. Is that correct, guys? Are we all agreeing that we pick stock Y?
Yeah, stock Y.
Stock Y, because the CV is low. Because we are saying here, CV is a measure. So CV is a standard deviation. I'm just saying standard, but the standard deviation mean ratio is smaller. It translates to less risk per unit of return. So that's what we'll be using. Let me not open too many slides. Let's go back. So we said, in a situation like this, we will now not just jump into conclusion on the efficient frontier. We will now need to make calculations of the CV, which is mean standard deviation mean ratio. I might choose to do the same on this. But what we need to understand is that the efficient frontier illustrates possible investment positions on risk investments. So all these dots, guys, they're just giving you the possible risk and return options. So this is a possibility. This is a possibility. This is a possibility. But you cannot just pick in, because they've got different risk and return trade-off. You need to identify the one that is best. Then we say the dots illustrate possible portfolios which can be constructed by an investor. The efficient frontier marks a list. The efficient frontier. So the efficient frontier, this is the green line. You see this green line, which is like this. The efficient frontier marks a list of the best possible portfolios of risk of assets. So what we are going to say, guys, you see that C and D gave us a lot of issues. Even if you want to come up here, guys, let's take this one. Let's take this is E and this is F. Let me not take that one. Let me take which one and which one. Let's take this one. Let me cancel. Let me take this one, which are far. Let's say this is E, this is F. If this is FE, the risk is here. F, the risk is here. There are a chance. My drawing may not be good. Okay. There are a chance. You see, there are a chance. You see, it's very difficult to come with this, with the conclusion. So now, the second statement saying the efficient frontier marks a list of the best possible portfolio of risk. So all investments or all portfolios which lie on this green line are the best. Why? It means that they've got the best return and the risk trade-offs. So if I'm going to draw this one, you see here, down, that's the risk. This is the return. This is the return. You find that considering all these ones, as much as these ones, this one might be providing much return, right? But it's got more risk. So this one, which lies on the efficient frontier, is the best because it has got better risk and return trade-offs. All the other options below, you've got two things. You might find that the other one has got more risky than the other. The other one has got more return, but it's got more risky. The other one might have less risky, but also maybe less return. So we're saying that from a list of the portfolios, the investor should choose an optimal portfolio which lies on the frontier. This is a portfolio that represents the best risk and returns trade-offs. According to Harry Markowitz, he aimed at providing a technique to create an optimal portfolio. We can deduce from the graph that all points below the graph, all these ones, I've put a lot of stuff here, but I want you to realize that all points below the graph, below this graph, we're saying this green line, that efficient frontier, that green line, all the points below that, it's no longer able to clear the other ones. As much as I'm deleting the other ones, this one should remain because it's our important point which lies on the graph. All other points below the graph, we can deduce from the graph that all points below the graph miss one thing from the portfolios or portfolio on the efficient frontier. They have a higher risk for the same level of return, or they have less return for the same level of risk compared to the portfolios that lie along the efficient frontier. We've learned, guys. Guys, ask you questions. Let's talk. Where are we not getting it? Are we together with this efficient frontier? We are saying all points below, with these blue dots, below the graph, miss one thing from the portfolio of the efficient frontier. They have higher risk. For example, do you see this one? We want to compare our best option here. Let's compare it with this one. Do you see these guys? They just have maybe the same, almost the same return. But why are we eliminating this one? It has got a higher risk. Though they might have the same or almost the same return, it has got a higher risk. So we're saying they have higher risk for the same level of return. Yes, the return may be the same, but they've got a higher risk, right? Or they have less return for the same level of risk. Do you see that if you want to compare this one and our ideal, they might have almost the same risk? If we're drawing the line here, you see they almost fall in the same line. But this one has got lower return. So all portfolios below the graph, they lack something. They've got either higher risk for the same level of return or less return for the same level of risk. You see, this one was almost close to the graph. And we could pick it, right? If we're going to draw it here and plot also its risk, and we want to compare with this portfolio, you see they're almost on the same level of return. But the reason why we will say this one below the graph is not ideal, it has got more risk. So The efficient frontier tries to explain the risk and return trade-offs and to suggest to us how can we pick an optimal portfolio. An optimal portfolio is the one which lies on the efficient frontier, and it suggests that that portfolio possess the best risk and return trade-offs compared to all other portfolios which are below. Okay, so we are saying here the lines represent the line represent the efficient frontier, the optimum combination of risk and return. We say each dot represents a portfolio. The closest to the efficient frontier have the potential to produce the greatest return with the lowest degree of risk. They have those closest to the efficient frontier, like this one, to the efficient frontier, have the potential to produce the greatest return with the lowest possible degree of risk. Guys, are we together on this efficient frontier? What questions do we have?